this session, we will discuss question number 2, how to find out quadratic polynomial when their sum of the zeros and product of the zeros. What is that? X square minus sum of zeros equals to 0. Okay. If we are given sum of the zeros and product of the zeros, we can easily find out the equation of polynomial. So polynomial is x square minus sum of zeros. So sum of zeros means 1 by 4 into x plus product of zeros, that is minus 1, is equal to 0. Now question number 5. So question number 5, sum of the zeros is, so x square minus 1 by 4 into x plus product is 1 by 4. So we will write 1 by 4 equals to, this is 4x square minus a 0, it gives 0. So this is the quadratic polynomial for question number 5. Hello everyone, welcome back to my channel. So in the previous video we will discuss exercise 2.2 and question number 1, and in this session we will discuss question number 2, how to find out quadratic polynomial when their sum of the zeros and product of the zeros is given. Okay, so I have copied from the book. This is the sum of the zeros and this is the product of the zeros, and question is that find a quadratic polynomial each with given numbers as the sum and the product of its zeros respectively. Okay, let me discuss what is the meaning of the word respectively. Respectively means if we are given two number. Suppose if I say in mathematics there is two numbers, so and we have given sum of the zeros and product of the zeros. So how can I say 1 by 4 is sum of the zeros and minus 1 is product of the zeros? So this is the word respectively. Respectively indicates that if the sum is written is first and product is written is second, so sum can be indicate this number and product can be indicate this number. If product is first and sum is second, in the second case is written, so that means it indicates that 1 by 4 is product and minus 1 is sum. Okay, am I clear? So but here sum and the product of its zeros respectively means sum is first written and then the product is written next in the next case. That means this is sum and this is product of the zeros. Okay, clear this topic. Now let us solve this math number 1. So okay, let us, before going to the question number 1, let us discuss one formula how to find out polynomial, quadratic polynomial. So there is a formula. What is that? X square minus sum of zeros into x plus product of zeros equals to 0. Okay, if we are given sum of the zeros and product of the zeros, we can easily find out the equation of polynomial. So what is the rule? X square minus sum of the zeros into x and plus product of the zeros equal to 0. Following this rule, we can find out question number 1. So question number 1, sum is given and product is given. So we can find, so polynomial is x square minus sum of zeros. So sum of zeros means 1 by 4 into x plus product of zeros, that is minus 1, is equal to 0. So x square minus 1 x, that means x by 4 minus plus minus 1 equal to 0. If I simplify it, you can write 4x square minus x and 4 into 1, that is minus 4 equal to 0. Basically we take LCM of these 4, here 1 and here 1 only. So this is the equation of the polynomial for the question number 1. Next question number 2. So we know that the formula is x square minus sum of zeros into x plus product of zeros is equals to 0. So x square minus sum of zeros is given root 2. So we will put root 2 here into x plus product of the zeros means 1 by 3. So we will write 1 by 3 equals to 0. Now we simplify that. So 3 is there. So 3 will be multiplied here and here only. So 3x square minus 3 root 2 x plus 1 equal to 0. If you want to know why ma'am these 3 is multiplied here and here, so basically there is nothing is there, means denominator is 1 and here also 1. So if I take the LCM of 3, LCM of 1 and 3, can write 3 and 1, how many is 3? 1 3 is 3, so 3 will be multiplied here also, and 1 how many is 3? 1 also multiply, 3 also multiply here also. That's why 3 root 2, 3 root 2 and 3 into x, 3x square, 3 into x square, 3x square, and here 1 will be multiplied here. Now 1 1 is 1, 3 1 is 3. So that's why we'll write this one, and 3x square minus 3 root 2 plus 1, and 3 will be divided. So 3 here will be multiplied, and 3 zeros are what? 0. That's why the result is 3x square minus 3 root 2 plus 1 equals to. For question number 3, the formula is same. This is sum of the zeros and this is product of the zeros. Let us put the this one, x square minus sum of the zeros is 0. So 0 into x plus product of the zeros, that is root 5 equals to 0. So x square minus 0 into x is 0, that is 0, and plus root 5 equal to 0. That is x square plus root 5 is equal to 0. Okay, so this is the quadratic polynomial here. Question number 4. So question number 4, the sum of the zeros is 1. So x square minus 1 into x plus product of the zeros, that means this one 1 equals to 0. So x square minus 1 into x, 1x plus 1 equal to 0. If I simplify that, x square minus x plus 1 equals to 0 is the quadratic polynomial for the question number 4. Question number 5. So question number 5, sum of the zeros is minus 1 by 4 and product is 1 by 4. So x square minus 1 by 4 into x plus product is 1 by 4. So we will write 1 by 4 equals to 0. Now x square. So here 1 is there. So 1 LCM of 1, 4 and 4, we take 4. So here 4 will be multiplied. So 4 1 ja 4 x square, and here 1 will be multiplied and 1, because 1 4 ja 4 and 1 4 ja 4. So 1 1 ja minus 1x and 1 1 ja 1 equals to 0. So this is 4x square minus x plus 1, and when 4 will be multiplied with 0, it gives 0. So this is the quadratic polynomial for question number 5. Let us discuss question number 6, and this is the last question of this session. So the rule is same, and we will put x square minus, this is sum of the zeros, that is 4x plus product of the zero, that is 1, is equal to 0. Okay, so this is the quadratic polynomial. So we discussed all the questions of question number 2. That is, we had 5 questions was there. So we discussed all the questions by one rule, and it has another rule also. if you want this rule, please comment me, ma'am, I want this rule. That I will upload the rule and all the method, all the maths by this rule. Okay. Thank you for today.